8, we're being asked to go backwards. Okay, there's a graph on question 8. It's 1, 2, 3, 4, 5. I think there's a point right here, and then it goes through there, and it goes through there. And we're being asked to write the equation. So the first thing we want to identify is the vertex, which is 3, negative 1. Okay, because that's where this point is right here. Now we remember it has this format, y equals a, absolute value x minus h plus k. So first thing I might want to look for is the slope. Well, I notice this graph goes up 1 over 1 on the right hand side. So that tells me the slope is 1. So I can say y equals the absolute value of x. Now I have to figure out, what am I subtracting? Well, this is h, and so when I write x minus h, I want to write x minus 3. Notice that the sign switch has occurred. Okay, and I can write plus negative 1 or just write minus 1, which is the preferred method. All you're really looking for is the equation that you would use to graph this. Now, if I graph this in my calculator, it had better look like the one on my screen. If it's in the wrong spot, so say for instance, I go and I write, let's get rid of the negative. Let's say that I hadn't switched the sign. Let's say I left it as plus 3 and minus 1. So this is the wrong graph. But when I graph it, I would notice this does not look the same. It looks like it should be over here. It's supposed to be over here. So maybe something's wrong with the 3. Go back there. I'm going to put that minus. Again, problem solving, guys. If something isn't working quite right, can you problem solve it? That looks a lot better for the graph that I hand drew, or the graph that was over here. So I like that a lot better. Okay, number 9. 9, 10, 11, 12, we're going to start getting into systems of equations and solving them. These are still some graphing questions. For number 9, we've got y equals 2x minus 4 and y equals negative 4x plus 8. So in theory, these are all graphable by hand, but I also understand if you have a little hesitation in that. 2, 3, 4, 5, 6, 7, 8, and down 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. If I were to actually try to graph these just by hand, this one starts at negative 4, and it goes up 2 over 1, up 2 over 1, and I would connect those connect a line through there, right? And that's fine. There's absolutely zero wrong with that. In fact, I think that's faster than graphing it in the calculator. However, I know some of you are going to want to do it with the calculator. So I'm going to show you the final step here. I go up to 8. I'm going to come down 4 over 1. I'm going to go 1. I was up too far. 1, 2, 3, 4, 5, 6, 7, 8. No, that's right. 8 down 1, 2, 3, 4. There we go. Over 1. And then I'm going to go down 4 more and over 1. It turns out that it's right there. The intersection's at 2, 0. Now I do have to have the two lines drawn through there so they look appropriately, and then my answer is 2, 0. Now what if I want to use a graphing calculator because I just don't want to make mistakes and I'm really concerned about the computation or how I would graph by hand? So I'm going to do it in the calculator real quick. We said it was 2x minus 4 and a negative 4x plus 8. And if I go ahead and graph those, do they look similar to the graph that I created? Yes. Does it look like they're crossing at 2, 0? Yes. To check, I can go to the table, which is the second function of graph, go to when x is 2, and you notice you have a 0, 0. That tells me 2, 0 is a point on both lines, meaning it's the solution. The other option is if I'm looking at the graph, I press second and trace because I want to do a calculate. And I'm going to calculate number 5, the intersect. And I'm just going to press enter 3 times so it can go through the process and comes up with 2, 0. There's multiple ways to get your answers here on these graphs. Okay. Question number 10. similar type of an approach. 2x plus y equals 2, and y plus 1 equals x. So the problem with graphing these in the calculator is that they're not in y equals form, so I have to make that happen. I'm going to minus 2x minus 2x. Y is now alone, right? Right here. I can graph that, and here I'd have to minus 1 from both sides. And so now I have y equals x minus 1. So I can go back to my calculator. Again, I could graph these by hand with zero problem, or I can graph them in the calculator. Because the calculator is the one that we'd be more likely to make mistakes with, as far as if you mistype something or something silly, you need to know the whole process. So I'm just going to continue to use that process. If I graph it here, looks like I'm getting a solution at 1, 0, I'm guessing. Second table, sure enough, 1, 0, 0, that tells me at 1, 0. If I do second trace, 5, enter 3 times, the intersection's at 1, 0. So I didn't actually plot any points yet. I need to do that now. I know that at 1, 0, I'm supposed to have my intersection. So I'm going to come in here, put a dot right there. I need to graph the other lines though. This isn't very hard. If I want to graph the other information, I'm just going to go to the table. And if you look at like 2, one of them's at 2, negative 2. So we went to 2 and to negative 2. There's a point. And then if I went to the calculator again, 2, 1 works for the other one. So 2, 1 works for the other one. That should be enough for me to real quickly come through this way and come through this way. And I have a representative graph. The table just gives you all the numbers you'd ever need. So 11 and 12, we're allowed to solve by substitution or elimination. No, there's not necessarily only one way to do it. There is a preferred or a setup. So I'm gonna do one each way, just because I think it's important that you see both options. So 5x plus 4y equals 32. All right, so what I see here is I see a y that I could get alone. All I have to do is add 3x. So I'm going to add 3x, and now I have what y equals. This is called substitution. That information is going to go in the other equation for y. 5x plus 4 times negative 9 plus 3x equals 32. I now need to distribute. I get 5x minus 36 plus 12x equals 32. If I add 36, and I'm going to combine these two, I'll get 17x equals 68. And if you divide by 17, x is equal to 4. Now to find my y, I need to plug this in up there, because I know that y equals negative 9 plus 3 times x, which is 4. 3 times 4 is 12. Negative 9 plus 12, y equals 3. So my answer would be 4, 3. Now, could I have done elimination? Yes. And I'm going to show you what elimination looks like on 12. So you can use either of these methods and not have any hesitation with what you're doing there. Okay, so negative 4x plus 9y equals 9, and x minus 3y equals negative 6. So this problem, I could also try to do substitution by getting this x alone. All I have to do is add 3y, plug that information in where x is, and do the same process. But if I times the bottom equation by 4 or 3, either one, I could get rid of the 9, or I could get rid of the y's, or I could get rid of the x's. I chose x's just because that's what I picked. I'm going to have 4x minus 12y equals negative 24. And the first equation I'm leaving alone. Negative 4x plus 9y equals 9. When I combine my like terms, the x's cancel. I get negative 3y equals negative 15. so y would equal 5. Now to find the x value, I need to plug that in. And I like this second equation. It says x minus 3 times y, which is 5, equals negative 6. Well, this is a negative 15, so x minus 15 equals negative 6. So we add 15, x equals 9. So my answer to this question is 9, 5. If you want to use this method on question 11, feel free to. If you want to use the method used on question 11 on question 12, feel free to. It doesn't make any difference in the way you do the problem. You might find substitution is harder sometimes, but generally speaking, on the test, it's probably going to be available to you either way. Question number 13 is the doozy. It's the big one that has all of our equations, lots of work. So it's 4x minus y plus 3z equals 13. That's equation number 1. Equation number 2 is x plus y plus z equals 2. And equation number 3 is x plus 3y minus 2z equals negative 17. Alright, so I want to try to find a way to eliminate some variables. And you might see some reasons to get rid of x, some reasons to get rid of y, some reasons to get rid of z. But when I look at this right here, a negative y and a positive y, that's a gimme. It's just going to happen right away. So I'm going to come over here, do equation 1 and equation 2. I don't have to change anything to get the y's to cancel, so I'm going to leave it just like it is. 3z equals 13, and down here I have x plus y plus z equals 2. My x's combine to make 5x. The y's cancel. I get 4z equals 15. It's important that I don't change anything now. I just eliminated y. So when I come over to do two equations now, I need to still change and get rid of y. So if I look at equation 1 and equation 3, I think that will be a good combination for me. 1 and 3. Equation number 1 has a negative y. To cancel with a 3y, it needs to be a negative 3y. So I'm going to times by 3. That makes 12x minus 3y plus 9z equals 39. Down here for line 3, I'm not changing it. It's x plus 3y minus 2z equals negative 17. Here I'm going to get 13x. The y's cancel again. Plus 7z equals 22. I'm going to call this, sorry, this was equation number 4 that I created, and this is equation number 5. I now want to squish 4 and 5 together and cancel one of them. I'm looking at them, and I think z is probably my best bet. I can make 4 and 7 turn into 28. So equation number 4 needs to multiply by 7, making it 35x plus 28z equals 70, and 35 is 105. But equation number 5 needs a negative 28x, so I'm going to times by negative 4. Okay, so thinking about negative 4 times that equation 5 would be negative 52x minus 28z equals negative 88. I'm telling you right now, I sure hope this doesn't mess up and blow up in my face, but I'm going to grab my calculator and hopefully all the numbers are working for me. I've got a 35, and I've got to subtract 52 because it's negative 52. That's a negative 17x. My z's cancel. And 105 minus 88, sure enough, is 17. I divide by negative 17, and x is equal to negative 1. Now I've got to find a way to find z and y. If I take this negative 1 and plug it in right there, I should be able to solve for z. So 13 times negative 1 plus 7z equals 22. This is really a negative 13, so I'm going to add 13 to both sides. These should then cancel, leaving me with 7z equals 35, meaning that z would equal 5 when you divide by 7. Okay, so now I know x, I know z, I need to find y, And I like equation number 2 because they're all singles. There's no multiplication to do. So x is negative 1 plus y, which I don't know, plus z, which is 5, should equal 2. The negative 1 and the 5 turn out to be 4, so I'm going to minus 4 from both sides. I'm left with y equals negative 2. So my answer would be negative 1, negative 2, and 5. And that's it. All we have left is the bonus question. Now the bonus question is pretty straightforward, to be honest, if you just kind of read through the question. It says you and a friend go out to Fiesta for lunch. You order 3 soft tacos. So I'm thinking 3T for 3 tacos. And so we're going to go plus 3 burritos. And you end up having to pay $11.25. Your friend goes with you and gets a $10 bill when he buys 4 tacos and 2 burritos. You might be thinking, hey, I got ripped off. I got 6 things, he got 6 things, and he got to save $1.25. So what we're going to do here is we want to try and use either elimination or substitution. Substitution will be harder on a question like this, typically, but it is possible. I'd probably go after this B, try to isolate it, but elimination is not bad either. I do have to multiply by a number to get these to cancel. I think I'll multiply the top line by 2 to make this a 6. That makes 6t plus 6b equals 22.5. And down here I'm going to times by negative 3. That makes negative 12t minus 6b. And that right there, that's the payoff. I wanted the b's to be opposite. Equals negative 30. This turns out to be negative 6t. Those cancel. Equals negative 7.5. When you divide by negative 6, grab a calculator. A negative 7.5 divided by negative 6 is $1.25. So a taco is $1.25. To find out what it costs for a burrito, I'm going to plug that into one of these equations. Let's do this bottom one here. So 4 times 1.25 plus 2b equals 10. Well, 4 times 1 1/4 turns out to be 5. So I can minus 5, minus 5. I get 2b equals 5. Divide by 2. b equals 250. So now I know the cost of a burrito and the cost of a taco. And that is the end of the review. Good luck. Come in with your questions, and let's get this first test nailed down. Thanks.